The most common question I get is, what makes SecureAire different and why is it necessary? I can understand the question because I started from that place as well. I've had media filters, electronic air cleaners, bypass HEPA filter, UV bulb, coil, UV airstream, ion generator, photocatalytic oxidizer. I've had it all in my homes and I've experimented with them. That is what we should all do, I feel. And I got a benefit from every one of those, I'm sure of it. So when I first learned about SecureAire, I was a little skeptical that its technology was really necessary, first of all, and secondly, did it work? Well, happily, I found out, yes, it did work. And was it really necessary? I sure think so. So let's take a look at the elements that go into a complete IAQ solution to all of the issues that could exist in a home. And I have these 5 listed. We'll go through them quickly, and then I'll come back and dig deeper into each one. First of all, as we're going to find out in a moment, it's going to be very important to have some way to remove the particles from the occupied space and bring them back to some place to capture them, all the way down, including the smallest airborne contaminants. Third, we want to have something that can destroy organisms that can harm us, pathogens, bacteria, virus, and we also want to be able to remove and absorb harmful chemical compounds, the VOCs, volatile organic compounds. Some technologies produce what are arguably harmful byproducts. We all know that ozone is something that's not healthy to breathe, and that's an example of one of those. And finally, we could put products in that could essentially function like cardboard, not like anything, let anything through. But we know that that wouldn't be effective, obviously. And so we have to figure out how to address these other concerns, but do it without negatively impacting the performance of the heating and cooling equipment. So let's go back to the first one and dive into that. One epiphany for most of us is that most airborne particles are very, very, very small. If you look at this graph on the far right are 100 micron size particles. Those you could see. On the far left, 1,000th of a micron. Of course, we'd never be able to see that. And then somewhere around the third of the way through, we see 1 micron size particles. Well over 90%, 95 or 6% of all the airborne particles by count, if you were to count them all, are under 1 micron in size. And these are called ultrafine particles. Remember, they include particulate matter and pathogens and VOCs. They're all particles from a science perspective. And viruses land right there among the smallest of the small, and also as airborne, which airborne viruses can be airborne once an aerosolized droplet of including a virus dehydrates or dries out, then there could be airborne viruses for as much as 3 hours in a space. So these are among airborne particulates, and they're also very, very small, and they are also a particle. ASHRAE says that particles below 1 micron are virtually unaffected by gravity and stay suspended in the air. Even normal air movements won't be effective at moving them from where they are back to a capturing device. So we have to have something to move these particles, to make them somehow get bigger so they have more mass and more surface area so they can be moved from where they are back to a capturing device. So number one, SecureAire has what we call active particle control that will do exactly what we're talking about. Similar to an ion generator or a photocatalytic oxidizer that creates charged particles, we're creating charged particles that will cause others to attract each other, clump up, get them bigger, and move them back to our capturing device. So there's number one. We developed our technology in clean rooms and hospitals, and in clean rooms and hospitals, they don't care about what happens at the filter. They don't care about what happens in the ductwork. What they care about is what's being impacted in the room. In clean rooms, there's a standard for determining the level of clean that you can have in clean rooms. And clean rooms are measured with laser particle counters at certain particle size ranges in order to determine the qualification of the clean room level. So you could have class 1 through 9. Depending on the particle size, you have to be able to measure the particle sizes, the number of particles at that size range in order to determine the classification. So this is my home 48 hours after I installed the very first residential SecureAire unit. And I had a laser particle counter measuring particles at 0.5 microns in size. You can see that in the lower left-hand corner, small, SM for small, 0.5 microns in size. And the chart shows the small reading at 7, and you can barely see the dot, 7.3, meaning 7,300 0.5 micron size particles in a cubic foot of air. So this is measuring an air sample and calculating the number of particles at that size range in a single cubic foot of air. That's how classrooms are, or clean rooms, I'm sorry, clean rooms are assessed. So when I started, it was hundreds of thousands of particles per cubic foot prior to turning the SecureAire on. Within 48 hours, I had dropped the particle count in my home all the way down to the equivalent of a class 6 clean room. Amazing. And that meant that we had to do something to take the smaller particles and get them larger and move them back to the cartridge and capture them. And that's what active particle control does. Number 2, the IQ solution has to have something to capture the small stuff. So if you have a product like an ion generator or a PCO or a UV bulb in the airstream, and it's maybe doing something to impact particles or pathogens, they have to be captured somewhere. So unless you have something that is in the duct and then can remove the smallest things, they're going to be captured by the house or your food or your nose, God forbid, or something somewhere, anywhere but in the filter, and maybe including the filter, depending on the airflow that you have. So MERV ratings identify the effectiveness of removing the smallest particles, and the higher the MERV rating, the smaller the particle that it collects. So if we have a MERV 8, that's going to be less effective than a MERV 9, 10, or 11, and so on. So SecureAire is actually a MERV 15, and if you look at the graph that ASHRAE publishes to show you the effectiveness of particles of all sizes at different MERV ratings, you'll see that there's a dip, that the most difficult particle size to capture is around that 0.3 to 0.5 micron size range. So that's why the testing is done at those levels, because it's the hardest particle to capture. And science knows that if you can grab that, then everything bigger is actually easier to collect. And as it turns out, everything smaller has characteristics that make it easier to collect as well. So in our testing, which is published in our literature and on our website, we compared SecureAire's technology to a MERV 14 HEPA filter in an operating room, and compared it over a week's period of time. We measured at 0.4 microns in this test, close enough. And in operating rooms, you may know that there are lots of air changes. In fact, 18 air changes per hour in an operating room, along with, in the operating room 3, the test one, we had MERV 14, and with our cartridge, we're rated at MERV 15. And side-by-side comparisons over a week's period of time, we reduced the number of particles in the air by 94% compared to conventional operating room technology, 18 air changes an hour, and a MERV 14 filtration device. Incredible performance, apples to apples comparison, validated, published. This is fact. So number 3, there has to be some way to kill and confirm that living organisms like bacteria, mold, mildew are actually killed. And non-living organisms, inert organisms like a virus, which is not alive, is inactivated so it cannot infect or cause us some harm. And in the study that I just referenced, we had Bacillus subtilis in a test environment, and it was measured at a certain level. And then we turned the SecureAire unit on, and within 3 hours, we virtually eliminated it. There was no bacterial viability within 3 hours, which was the fastest of any technology tested by a long shot ever, according to Dr. Mark Hernandez, who is the #1 guy at doing testing for organizations like this. So we got to 0. And if you can kill Bacillus subtilis, that's like King Kong of all pathogens, then viruses and lesser pathogens are very, very simple to kill, or in the case of a virus, inactivate, render it incapable of infecting a host cell. In terms of VOCs, we're in hospitals all the time, as you could imagine. And in this example, we put a small unit in a test room and measured the VOC level, 4.6 micrograms per cubic meter. And within 30 minutes, almost eliminated it down to 0.34, or 92% of the VOCs were removed from the space. And the odor that had been prevalent from smoke and body odor and that sort of thing, and that happens in healthcare facilities, have been eliminated completely. So proof that we not only can remove the particles, which you saw in the operating room, that we can destroy the pathogens that you saw in the Hernandez test, that we can absorb the VOCs and eliminate them from the space, proven here in this example. All of this was published in the American Journal of Infection Control just a couple months ago. This article is on our website, and if you can get published with a study in the American Journal of Infection Control, you have accomplished the most stringent testing and have proven with the best possible methods and to the highest possible standards that your product does what it says. This is where doctors and scientists go to find out what really works and what doesn't. So then #4, creating byproducts that could be damaging to our health is actually common among certain technologies. Any ion generator or electronic air cleaner or photocatalytic oxidizer has to produce, by its nature, a certain amount of ozone. Now, it might be a very low level. I'm not saying it's dangerous, but I'm saying the technology has to produce some. And some of those technologies, like photocatalytic oxidizers, also have other byproducts called hydroperoxides, or it's a hydroxyl radical, actually. Sometimes they're referred to as friendly oxidizers, and all of these things oxidize, or they destroy organisms. Well, our lung tissue is a living organism, and hydroxyl radicals and ozone, as we've discussed, are not healthy things to breathe. So I'm not saying these products are bad, but I am saying that if you have technology that would produce 0 harmful byproducts compared to some, then the technology that would produce 0 and accomplish everything else would have to be somewhat better than the ones that produce some. So this information is available online for you to read. And if you look at the journals I've referred to you in the last section with the EPA document on residential air cleaners and the ASHRAE document, you'll find plenty of information about this. And the test that we prescribe to is the UL 867 test. And when that test is done, you're measuring ozone 1 inch from the downstream side of the filter, or in our case, the cartridge, and we produce 0 ozone. Finally, we don't want to negatively impact the performance of the heating and cooling system, and that means restriction to airflow. So as all filters get dirty, they naturally are going to increase airflow, and we talked last time about the negative impact of that on equipment performance, comfort, longevity, repairs, and that sort of thing. So our pressure drop curves are incredible. We're at 0.14 inches at maximum airflow. If you put a 3-ton unit on our unit that's rated at 1400 CFM, you'll actually be a tenth of an inch or lower. Remarkable. And it's not only initial static pressure that's low, but our cartridge will hold 3 times more contaminants than even a MERV 13 filter will, meaning that it'll last 3 times longer. So it's going to be very common that you experience 6-month life with not out a significant increase in static pressure. You could even go a year. When you sell a SecureAire, we're encouraging you to include the first-year service agreement and the first replacement cartridge. Then your technician goes out and does a digital manometer check across the entire cabinet. So drill the holes on both sides of the cabinet, use your digital manometer, measure the static pressure across the unit when it's installed, record that, and then you do it on the first call when it's serviced. And if it has only gone up 0.02, 3, or 4 inches, you're going to be good for another 6 months. If it's gone up and it's now at 0.25 or so, then you've determined that the replacement interval is every 6 months. Okay, so that ends this section, and once again, bringing you the safest, healthiest, and cleanest air possible today.